So we identified this as a weak topic when we were doing these questions on acids. So it's basically, how do I know what the formula is going to be? A lot of the time we learn that, if I well, okay, let's go through it. It's basically to do with, how do I know what charge is the ion going to be? These are all ionic compounds. So in the case of magnesium oxide, if you look on the periodic table, you'll notice that magnesium is in group 2. So that means it's got 2 electrons in the outer shell. So what happens when it becomes an ion? It loses those 2 electrons. It becomes Mg2 plus, and then you got the 2 electrons. That would be a nice half equation to show the ionization of magnesium. But the main thing we need to know is that it forms this magnesium ion here, because it needs to empty its shell. All metal atoms empty the outer shell. They all lose electrons and therefore need to empty the entire outer shell because the one beneath it is full. They're all atoms. When they become ions, they're trying to form full outer shells. Now, oxygen it's in group 6, so it's got 6 electrons in the outer shell. It has space for up to 8, so it needs to gain 2 more. Okay, so oxygen needs to gain. I'm not going to do O2. I'm just going to do the oxygen atom for now. It's a little bit incorrect, but I'm just going to do it like that to keep it simple. So we've got O2 minus. So in terms of the charge, we can say that the oxide ion and the magnesium ion, they work well as just a one-to-one. All right, they neutralize each other. So the formula for them, which is going to be MgO. Now, you could also think about it in terms of that magnesium donated 2 electrons or lost 2 electrons, and oxygen needed to gain 2 electrons. So in looking at it that way, we can also see it works well for one-to-one. This doesn't work as a one-to-one, and that's because magnesium is in group 2. So, and this is when people think, oh, magnesium is going to lose 2 and chlorine is going to gain 1, but we've moved the 2 from here to over here. That's a nicely identified pattern, but it's not demonstrating a full understanding of what's going on. The reason why the numbers change around, and they do always change around like this, but the reason is important. The magnesium, as we saw, forms an Mg2 plus, and chlorine is in group 7, so chlorine will form Cl minus. So chlorine only needs to gain, let's just make sure that was like a lowercase l. Chlorine only needs to gain 1 electron. So we could think about it in terms of the amount of electrons it needs to gain. The 2 electrons that came from magnesium can go to 2 different chloride ions, two different chlorine atoms, sorry. And then we form, so you got 1-to-2 ratio, or you can think about it in terms of the charges balancing. So you've got Mg2 plus, and then you'd have to have 2 lots of this to balance it out. So you've got MgCl2. I've already got it there. Let's have a look at the rest of them then. So we've got, I'm just going to make this pen a bit thinner. Calcium oxide. Calcium, I know, is in group 1. Oxygen's in group 2. So calcium would become Ca plus. Oxide is O2 minus. So I need another one of these to cancel out the charges. So the formula is Ca2O. Okay. Next one, calcium chloride. Calcium chloride. Well, we've got Ca plus, and we already know that chlorine is Cl minus, so works well as a one-to-one. I'm thinking about it in terms of charge here, but again, in terms of electron transfer, we can say this one lost 1 electron, this needs to gain 1 electron. So again, they work well as a one-to-one ratio. So CaCl. Aluminium oxide is always a very classic kind of the extension question, or the hardest question, if you like, because both the aluminium and the oxygen have numbers. So why is that? Well, aluminium is in group 3. So it loses 3 electrons, Al3 plus. Oxygen gains 2 electrons. Now, those two numbers don't balance, do they? So what I do is I add another one of these, give me a total of 6 plus, and I add 2 more oxide ions. And so we got 6 minus, again it neutralizes, or if you like, 6 electrons get lost from here and 6 electrons get gained from here. And so we've got Al2O3. So you notice that the numbers do always change, but the explanation is really important. So aluminium chloride then, well, aluminium we know forms an aluminium 3 plus ion, chlorine is 1 minus. So how many chloride is 1 minus, how many chloride ions do we need? We need 3 to balance it out. So it's going to be AlCl3. Okay, so what I'm going to do is I'm going to erase all of those notes, like the question though, and then you can have a go at that and use the video to help. Okay.